Bismillahirrahmanirrahim. This is me, Miss Aisha Manzoor, and you are watching my channel Chemistry Solutions. The objective of the lesson is to calculate empirical and molecular formula from relevant data. So what basically empirical formula is? Empirical formula is the simplest formula which represents the composition of a compound is called the empirical formula. So in any empirical formula problem, you must first find the mass percentage of element in the compound. Like in this question, we have given that 15.8% of carbon and 84.2% of sulfur. So in order to calculate the empirical formula, we will change the percentage into grams. So this percentage we will change into grams, 15.8 and 84.2. So next we have to divide all of these masses by their respective molar masses. So carbon has 12 molar mass and whereas sulfur has 32. So after calculating the moles, we will get the answer for carbon is 1.316 and for sulfur we will get the value 2.631. So in the next step what we have to do? We have to identify the smallest answer of moles and divide all figures by that. So smallest figure is the 1.36. So we will divide this value by the smallest figure, that is 1.316. So all the 1.316. So answer for carbon is 1 and for sulfur is 2. So in order to write its empirical formula, we will write it like this, CS2. So CS2 is the simplest formula and called as the empirical formula for the carbon sulfide. So this is the way and the steps through which you people will be able to calculate the empirical formula for compound. Another question, we can do it by the same way. First of all, we will change the percentage into the grams. We are having here carbon, hydrogen and oxygen elements. We will calculate and by writing the values 40.0 of carbon, 6.7% of hydrogen and 53.3% of oxygen is given. So in the first step, change the percentage to grams and now we are going to calculate its number of moles. Carbon is of 12, hydrogen molar mass is 1 and oxygen molar mass is 16. So divide all the masses of their respective with their respective molar masses and after dividing it with their respective molar masses, we will get the answers. For carbon is 20. For hydrogen, it is 6.7. For oxygen, it is 3.33. So pick the smallest answer of moles and divide all the figures by that. So here, what is the smallest value? Smallest figure is the 6.7 or 3.33. 3.33 is the smallest figure. So we will divide all of these three values with the smallest figure, that is 3.33. So after that we will get the answer for carbon, that is 6. For hydrogen it is 2 and for oxygen it is 1. So if we will see that the answer for the empirical formula is C6, H2 and O1. So this is the way through which you people will be able to calculate the empirical formula. So same methodology will be adopted. This is the way through which you can memorize and remember how to calculate the empirical formula. First of all, mass of atoms, mass of A atom and mass of X atom is given. There are two masses of atoms are given. We will calculate the number of moles by dividing it through its masses by the respective molar masses. So moles of A atoms will be obtained and moles of X atoms will be obtained. So divide all by the lowest number of moles. First of all, we will identify the uh, lower figure. Then we will divide it by the lowest number of moles and get the answer. And convert the ratio in the lowest whole number. And then you people will get the empirical formula. So here is a question where we have to calculate the molecular formula. So question is determine the empirical and molecular formula for chrysotile asbestos. Has the following percent composition: 28.03% magnesium, 21.60% silicon, 1.166% hydrogen, and 49.21% of oxygen. And the molar mass of the compound is given, that is 520.8. In the first step, we will write down and note down the name of the elements. That magnesium is given, that is 28.03. Then silicon, that is 21.60. Hydrogen is there, 1.16, and for oxygen it is 49.21. So here are these are the values which we have to utilize to calculate the empirical formula. In the first step, we have to calculate the empirical formula. So what we will do and what we have to do. First step always remains similar, that the change the percentage to grams, and after changing the percentage into grams, divide all the masses with their respective molar masses. And for magnesium it is 24, for silicon it is 28, for hydrogen molar mass of hydrogen is 1, and for oxygen the molar mass of oxygen is 16. So after calculating the number of moles, we will get the answers that are 1.167 and 0.771. For hydrogen, 1.16 again, 3.07 for oxygen. And if we will identify the smallest answer of moles, then we will divide all the figures by that. So the smallest answer here is the 0.777. So we will divide all the values by 0.771, 0.771. By dividing all of the values, we will get the empirical formula. So after dividing these values, we will get the answer, that is 1.5 for magnesium. For silicon is 1, 1.5 for the hydrogen, and 4 for oxygen. So this is a way through which we will calculate the empirical formula. But if we have a look on the answers, but answers are not close enough to the nearest whole number. So if the answer is not close enough to the nearest whole number, we must choose a factor to multiply all the figures by, that will yield us whole numbers. So by this, what can we do? We will multiply it to get the whole number. We can multiply 1.5 by 2. So we will divide this value with all of these numbers. After multiplying these values, we will get 3, 2, 3, and 2. So this is the way through which we will get the whole number. After getting the whole number in the formula, the coefficient calculated in this step will become the subscript in the chemical formula. How we will write it in the subscript formula? Like this. This 3, Mg for 3, I am writing the formula Mg3, and here this silicon is 2, hydrogen is 3, and 2 fours are 8, oxygen is 8. So this is the way through which you people will be able to calculate the empirical formula of the compound. But here we have another value in this question, that is the molar mass of this compound, that is 520.8 gram per mole. So the next step, how we will able to calculate the molecular formula. So in order to calculate the molecular formula, we must know the mass of the empirical formula. So if we know the atomic mass of magnesium is 24 multiplied by 3, silicon is 28 multiplied by 2, for hydrogen 1 multiplied by 3, and for oxygen it is 16 multiplied by 8. After calculating its molecular mass, we will get the value of 259. So in order to calculate the molecular formula, we need the value of N, and N is the value for the molecular mass or molar mass of the compound. Molar mass of a compound will be divided by the empirical formula of the compound. Empirical formula mass. So the value of molar mass which is given to us in this question, that was 520, that is 520, and we will divide it by 259. After dividing these two value, we will get the answer, that is 2. So now how we are going to use this value to calculate the molecular formula. So molecular formula is going to be calculated by using this formula. Molecular formula is equal to N multiplied by empirical formula. So I am going to abbreviate these words. So we have got the value for molecular formula, and we have got the value. We will write here our empirical formula that we have calculated, that was Mg3 Si2 H3 and O8. So we can multiply this value by 2 and get the answer. That is Mg4, Mg6, Si4, H6 and O18. So this is the way through which you people will be able to calculate the molecular formula. By the end of this lesson, you people will get the different questions through which you people will practice these concepts. So here is another question for hydrated salt. 210.4 gram hydrate of Epsom salt MgSO4 NH2 was heated up. The water was released and the final anhydrous mass was 120.4 gram. What is the formula of this hydrate? So determine the mass of water that has left the compound. Actually, here is the hydrated salt. MgSO4 and H2O has the mass that is 210.4 gram. So 210.4 gram is the mass of hydrate of Epsom, meaning that this salt is the hydrated salt and has the water of crystallization in it. So take the mass of hydrated salt, that is the 210.4. This is the mass of hydrated salt, and subtract the mass of anhydrous. This is the mass of anhydrous. After heating this compound, we will get the mass of anhydrous without, that is MgSO4, without water. So mass of anhydrous salt is 120.4. So we will subtract this value and to get the mass of water. After subtracting these values, we will get the value, that is 90 gram of water. So in the first step, when we will have a question like this, we have to subtract the mass of hydrated salt from the anhydrous salt to get the mass of water. So this is the way through which we will get the values for anhydrous and hydrated salts. So now what we will do, we will write anhydrous salt here in order to calculate the value of N, and we have to write the mass of water molecule here. So in the first step, we will write the mass of water, that is 90 gram, and we will write the mass of anhydrous salt, that is 120.4. So after having these values, just like to calculate the empirical formula, we will calculate the number of moles of these compounds. But here we will use the molar mass of compound. That the molar masses of the compound MgSO4 is 120, and for water it is 18. So after calculating these values, we will get the value here 1 and 5. So divide all the masses by their respective molar masses and we will get the answer 1 and 5. For magnesium sulfate, 5 for H2. But here pick the smallest answer and divide that smaller answer by the all figures. So we will get the answer, that is here 1 and 5. So now we can identify the value of N in MgSO4. So we will write the value of MgSO4 like this. MgSO4, and the value of N is 5. This is the value of N. So we have to write value of N 5 H2O. Here we will write 5 H2O. So this is the way through which we will be able to calculate the formula of hydrated salts as well. So by the end of the lesson, I will provide you some of the questions through which you people will have a look on the practice questions to solve those questions. Here is another important question. If the percentage of water in magnesium sulfate crystals is 51.2%, what is the N in the magnesium sulfate? So here you can identify which value is given to us. There is not a value for the hydrated salt and not a single value of anhydrous salt is given. In this question, if the percentage of water in magnesium sulfate crystals is 51.2%, what is N in the formula magnesium sulfate NH2O? Remember that when we say that the percentage of water in the crystal is 51.2%, then it means that 100 gram of crystals contain 51.2 gram of water. So if we can consider these crystals 100 gram, so if we will minus the value of 51.2 gram of water, then we will get the answer for the uh, mass of the crystals, that is MgSO4 48.8. So anhydrous, in the anhydrous salt magnesium sulfate has the value 48.8, and whereas water has the value, that is 51.2 gram is given. Again, I'm repeating that when we say that the percentage of water in the crystal is 51.2%, we mean that 100 gram of crystals contain 51.2 gram of water. So the difference 48.8 gram is the mass of magnesium sulfate. So this is the mass of magnesium sulfate. Now we will divide all the values through its molecular masses. So after dividing it 48.8 by 120 and water by 18, we will get the answer, that is 0.406 and the here 2.85. Now what is the smallest figure? The smallest figure is 0.406. So we will divide all the values by the smallest value, that is 0.406 and 0.406. So after dividing both of these values, we will get the answer, that is the answer will be 1 and for water the answer will be 7. So by the end we can write it like this: MgSO4 dot 7H2O. So this is a way through which you people will be able to calculate the value of N in hydrated salt. Now here are some of the questions. You people can take the screenshot, or you people can pause the video and solve all of these questions to practice this concept. Here is another for the hydrated salts to calculate the value of N. This is the way through which you people will calculate the molecular formula and empirical formula from the relevant data. I hope so that you people have learned it very well. Consistency is the key of success. If you people have learned a single word, so don't forget to subscribe my channel and hit the bell icon. Signing off, Miss Aisha Manzoor.